All right, today we're going to talk about lesson 62. We're going to cover complex numbers. So as of right now, if we have the square root of a negative number, we say that there's no real solution because we can't find the square root of a negative number. But today we're going to talk about finding, being able to simplify and actually find a solution to a problem like this. So we're going to introduce imaginary numbers. And when you involve imaginary numbers, you can now find the answer, the solution to a square root of a negative number. So when you have square root of negative numbers, now we're going to have a way to finish out our problem. We're going to use lowercase I to represent any imaginary number. There's a couple key things that we need to know. I squared is always going to be equal to -1. Okay, so if we have to solve for I itself, we would take the square root. So the square root of -1 would give us I. So these two pieces of information are going to help you simplify problems when you have negative square roots. So we'll look at an example. We're going to take what we started with, square root of -25. Well, we can break that into square root of 25 and the square root of -1. We know the square root of 25 is plus or minus 5, and the square root of -1 we just talked about being I. So our answer for square root of -25 would be plus or minus 5I. We can look again at square root of -16, just another very similar example. Breaking into its two pieces, square root of 16 is where we get that plus or minus 4. Square root of -1 is where we get the I. Our answer has always been in the form BI. So the I stands for the imaginary. That B is just any real number. So we had 5, we had 4, both positive and negative versions. So anything in the form BI is going to be an imaginary number. I want you guys to find -2 times the square root of -49. So go ahead and simplify that now. We're going to look at this example. So square root of -117. We can break this down a couple different ways. So the first thing we want to do is break it down and get rid of that -1. So pull that -1 out into its own radical. And then we're looking for perfect squares that go into 117. Well, 9 goes in. 9 times 13 would give us 117. So we broke -117 into square root of 9, square root of 13, and square root of -1. Solve it piece by piece. So square root of 9 is plus or minus 3. Square root of 13 we can't do anything with. And square root of -1 we know is that I. So altogether we have plus or minus 3I times the square root of 13. Okay, we're going to take a quadratic function and we're going to solve this. So our goal is to get x alone. Well, in order to get x alone, we're going to start by subtracting 25 from both sides. Now we have x squared is equal to -25. To get rid of that squared, we have to do the inverse operation, which is going to be square root. So we need to square root both sides. Well, square root of -25 is, just like we talked about on the previous page, plus or minus that 5i. So in this example, our x value is plus or minus 5i. Now we're going to introduce complex numbers. So everything we've done so far has just been imaginary. It's just been one term. Complex numbers are always going to be in the form a plus bi. So we still have that imaginary part, but we're going to add something out in front. So that a is any real number, and then that bi in its whole or its entirety is going to be the imaginary part. Okay, so a complex number has that a and then plus the imaginary number. Here's a couple examples, just really basic. We have a 3 plus 2i. You can also have some negatives in there. So -7 minus 5i. You could have 10 minus 6i. Anything with those two parts is going to be a complex number. Okay, when we go to add and subtract complex numbers, we're going to do that component-wise, meaning you're going to add the real number part, and then you're going to add the imaginary part. So here's an example, 7 plus 4i plus -2 minus 5i. Each of these pieces are complex numbers in themselves, and now our goal is to combine them by adding. So we're going to take 7 plus -2. Well, 7 plus -2 is the same as 7 minus 2. So we'll get 5, and then we're going to take 4i minus 5i. So we get a 5 minus a 1i, or 5 minus I. Here, if we subtract, just like any other piece of, or any other polynomial that we subtract, we have to distribute that minus all the way through. So this is going to be a 5 minus 3i. If you distribute it, it would be a minus 5i plus 11i. Well, 5 minus 5 is going to give us 0. Negative 3 minus negative, that would turn into a plus. So negative 3i plus 11i would be a positive 8i. That 0 is unnecessary, so that simplifies to just 8i. I'd like you guys to go ahead and subtract these two complex numbers. Now we're going to take another quadratic function and we're going to solve this one. This one's a little more involved. Right away, though, we can start by taking our square root. So we're going to square root a negative number. Well, that leaves us with x minus 3 on the left side. And then the right side would be equal to plus or minus the square root of negative 4. It's really important we remember that plus or minus sign anytime we're taking the square root of a number. So square root of negative 4 is going to be a 2i. So now we have x minus 3 equals plus or minus 2i. Last step would just be to add that 3 over. Our final answer then is 3 plus or minus 2i. Technically, that's two solutions. You have 3 plus 2i and you have 3 minus 2i. Okay, complex number. You have your real number part, imaginary part. I would like you guys to solve this one using similar steps that we used in the example before. Okay, one more example that we're going to do together. Here we need to solve this quadratic formula. It looks a little different than the last two examples we've done because it's not a perfect square. So this is written out in standard form. We learned how to complete the square the other day, so we're going to use that complete the square method to solve for x here. Remember, our first step is to get that constant to the right side. So we're going to subtract 18. So we have x squared plus 8x equals negative 18. Here we're going to have to take half of that b value and square it and add it to both sides. Well, half of 8 squared looks like that. Obviously simplify, so 8 divided by 2 would be 4. So you're adding 4 squared to both sides. I went ahead and rewrote that as 16 over here on the right side. Okay, left side now needs to be factored. So this becomes x plus 4 quantity squared. Simplify the right side, you get a negative 2. Now this looks like our problem above. So now we can take the square root both sides. On the left side, you're left with x plus 4. Square root of 2 does not come out nicely, so we just pull the I out. Because remember, you could rewrite this as negative, square root of negative 1, square root of 2. Square root of negative 1 is where we get that I. Any square root needs plus or minus. So we have plus or minus I root 2. Last step would be to subtract 4. So we're subtracting 4. Our final answer is negative 4 plus or minus I root 2. Again, two different answers there. Quadratic, we're used to having two answers. Last thing I would like you to do is to simplify this one on your own or solve for x. Again, you'll have to complete the square.